Good morning students. Today we will be learning regarding the console input output variables and reference variables, function prototyping and function overloading under the module 1. So let us begin with the console output. Console output is similar to your printf statements what you have seen in the C programming. So it is just to display the output to the screen, that is C out. It is nothing but it is written as C out over here. You are going to write C out with left shift operator. So these two are togetherly written to print the statement to the console output. Now this is defined under the class called ostream.h. ostream.h class. So this C out is nothing but it is an object that is being defined under the output stream.h. So you can see C out is an object of ostream class, and then C out is used together with the insertion operator. So this operator, left shift operator, is nothing but the insertion operator, which is written as double. Okay, so the left shift operator has its definition extended in the C++. So over here we can also write, in case if you want to introduce a new line in the program, then you can write end L instead of slash n. You might have seen in the C programming we used to use slash n for the new line, whereas in C++ we are going to use end L. Okay, so it is a predefined. C out is nothing but it is a predefined object that represents the standard output stream. C out is nothing but a predefined object. It is a predefined object which represents the standard output stream. Your standard output screen is nothing but the screen. The operator, whatever this you're going to use, right, it is called the left shift operator, and it is also called either as an insertion operator or put operator. And this left shift operator takes two operands, one in the left hand side, other one in the right hand side. In the left hand side it's always C out. In the left hand side it's always C out. In the right hand side you can write anything that you're supposed to print. In the right hand side, value on the right hand side of the insertion operator, you can write anything that you're supposed to print on the screen. Okay, so remember that C out is similar to the printf statement and it is defined under the ostream class. So this is regarding the console output. So this is an example for the console output where even Cin is being defined. So let us take this particular example. Ash include iostream.h. So here this iostream is nothing where C out, that is print, C out is for the printing, as well as the operator, that left shift operator, is being defined. In addition to this Cin, where input object as well as the right shift operator, that is to be read, and that is been defined under the iostream, where I stands for the input and O stands for the output. So this is the header. So this header can be of any type, like you can write it as just iostream, or else you can also write it as iostream.h, or else you can also write as iostream.hpp. So you can write in this way anyhow, depending on, based on the compiler which you are going to use. Okay, and then what is the use of this using namespace std? Now for example, in a class, if there are two persons of the name same, for example like Smita, okay, so in a class there are two people with the same name Smita. Now how will we identify? Based on their surname, like either their surname might be different, or else we basically identify based on their parents' name. So in such cases, now for example, again in such cases there will be complex, right? And for example, if there are two function names with similar ABC, again ABC. Okay, to identify, to manipulate these such issues, namespace is designed. So it is to overcome this difficulty and is used as an additional information to differentiate similar functions, classes or variables. Now this namespace std is used as nothing but to differentiate between these, based on their differentiate between the similarities based on their features, like it may be due to functions, classes, variables, etc. Here std is nothing but the namespace, it is a namespace where C plus libraries are defined, and we are going to use the term using over here, which where using namespace std, which helps to differentiate between the similar objects. Now for based on the additional information, it helps to differentiate between these two functions. Now for example, if Smitha is there, how will we fetch the more information? Either by their parents name or by their surname. So similarly, if the similar functions are there, it will differentiate by using this particular header, using namespace std. So this is regarding to one header file #include iostream.h, another one is regarding the namespace, which is used to differentiate between the similar functions or the class or variables or functions by fetching the additional information to differentiate the similar classes or function. Next is regarding the program. We begin with the int main. So in this int main, I have declared two variables, int x comma y, and then enter two numbers. So the first one is x and y. Okay, so for example here, int x comma y are the variables that has been declared. C out, as I told, C out is nothing but similar to the printf statement. You need to write enter two numbers, whatever you want to print, those statements you're writing within the double quotes. So enter two number, then you're taking the input is nothing but the scanf. If you remember, in the C we used to use the scanf, right? So here we have cin as the object name, and then extraction, we had insertion operator and left shift operator, which was also called as we had left shift operator, which was called as an insertion operator. This was then called as an insertion operator, where this is called as an extraction operator. So this is an object extraction operator. Over here we have, in the left hand side, it is a fundamental data type, a variable fundamental data type. So here you can see x and y. So you can cascade two variables by using same right shift operator. That means you can read two x and y from the screen, and then you can print again. So here int x and y I have defined. Cout is I'm just displaying whatever is there in this to the screen. Enter two numbers. I'm reading from the keyboard using cin object, and then cout again I have written you entered whatever the x value you want to print. If you want to just print the value of x, then you should write just x without any double quote, then tab, and then again y, and then again endl means it is a new line. Again cout displaying constant value, just I'm writing displaying the constant value 10, endl written 0. So here firstly it will print this, enter two numbers. You entered 1 2. I'll give from the keyboard, you will enter two numbers. Cin means you will enter two numbers. For example, 1 and 2 you have entered. You entered 1 and 2, and next line it will be printed. You entered 1 and 2, and next line it will printed displaying the constant value 10. So this is nothing but the program for the cout. So I'll just repeat the cout explanation. It is an output operator. Cout is an output operator. Okay, output operator. It is a predefined object. This is a predefined object that represents the standard output stream. Standard output stream in C++. Okay, here the standard output stream is nothing but your display or your screen, and the operator this is nothing but left shift operator. It is a left shift operator. It is used for insertion or put. This takes two operands, one in the left side, other one in the right side. This left side is always an object, that is your cout, and value on the right side of the insertion operator, it can be a value of some fundamental data type. For example, it can be any statements, like you can write any statements over here, hello world, or you can just display the value of x. Now if you declare x is equal to 10, and if you want just to display the value of x, then you just write the variable name. If you want something to be printed, then it should be within the double quote. If you want to print the value of this particular, then you're just writing x. So this is regarding the console output, and this is again defined in the ostream class. So that's why if you in the program, if you're using cout or cin, then you should include this header file #include iostream.h. main.h. So same in main, you already know it's a main function, and then I declared two variables x and y, and I've read to enter two numbers, and I've read using this the two numbers, and then I've displayed these two statements. So you can cascade any number of left shift operators, but if you're using a statement, then you must mention within the double quotes. If you're just displaying the variable value, then just the variable. And here if you write end L, that means it's an end of that particular line. Next line will be executed with this particular line. So this is regarding the IOC out. Next is regarding the console input. In the console input, the C++ stream object is defined to access the standard input in C. So how you've seen the scanf, in the C programming, Similarly, instead of scanf, we have here cin. And this is the extraction operator. Why extraction operator? And it is a right shift operator. You are going to extract the things from the keyboard. Okay, and cin, this is the object of iStream class. That is nothing but input stream class. Okay, right shift operator, whatever this operator is there, it acts as an extraction operator, and it is a binary operator, takes two operands, one on the left side and other one on the right side. Now whatever in the left side is nothing but your cin, which is an object of the iStream class, and whatever the right side is nothing but some variable of fundamental data type. It gets its value from the keyboard. This value is fetched from the keyboard. Okay, so this is regarding the console input. So you're writing in terms of cin, and then you're going to write in the right shift operator. Okay, so let us see the example for this. Same thing, as include IOStream, where input and output is been defined. That is nothing but cin, cout, as well as the insertion operator and the extraction operator, and then you're using namespace std in case if any conflict of functions or variables or classes will occur. We are going to use this particular using namespace std. Okay, and then in main, I'm going to declare two variables int x and enter two numbers. So I've taken x and y. Cout, you entered x, this is a tab, and then y, and end L, return 0. So enter two numbers, you have entered 2 and 4. So this is the output. So just remember, instead of scanf, you have cin. Instead of printf, you have cout. The possible errors for the cin, cout, and cout, let us check. So for example, cin, x and y is there. So this way of writing and cascading is valid, because you have written cin, you have read the variable x, and then you have read the variable y, and here you have put this semicolon. So this is a right statement. Whereas cin, then you have written x and put the semicolon, that means this is the end of that. Then again, if you put this operator and then you write y, okay, you put extraction operator, that is right shift operator, and then if you write this y, then it is an invalid. Just note the differences. If you are reading two variables at the same time, you can insert this right shift operator twice, but you shouldn't place any semicolon in between. If you are written this way, that is cin, insertion operator over here, that means cin and right shift operator and x, and then you put semicolon, and then again you have inserted y, then it is an invalid. Statement. Okay, then in the cout, you can write, if you write this way, /n, and then if you write name, okay, then if you write name and then you write this name this way, then it's invalid. This double quote should be there from here itself. Okay, this is how you're going to write. This is what are the possible errors you're going to get. So this is regarding the example of both the cin as well as the cout, console output and console input. So I hope it's clear with the console input and console output. Now let us see the variables in C++. So the variables in C++ can be declared anywhere inside a function and not necessarily at the beginning. You can declare variables in C can be declared anywhere within the function and not not necessarily at the beginning, that is globally. Okay, so here you can just an example for the variable declaration. So here you can see same iostream.h namespace std and then void main, and here I have declared the variable int x is equal to 10 and I have printed cout left shift operator, and then within the double quotes I have written x equal to, within the double quote x equal to, whatever you write within the double quotes it will be printed. You can see here x is equal to, and just if you want to print the value of that particular x, then you have to just write x. So then cascading over here twice in the single itself, you can write either this way, cout x equal to, and then again you can put a semicolon. Okay, if you just want to end over there, or else you can write both the statements together, x equal to, again left shift operator, and then you write x, and then again I have written int y is equal to x. Now what was the x value? It was 10. So here this x is equal to 10 is been printed. Now this, whatever the value of x, y is equal to x means whatever the value of x is stored in y, that is y will be equal to 10. Then cout within the double quotes y equal to, and y is being written over here, cout within the double quotes y. Now y will be printed over here, and then y, what is the value of y? Y is also 10, so that will be printed. Next I have written declared in sum equal to x plus y, and then I have displayed the sum. So this is how we are going to declare the variables in the C++. This is how we are going to declare the variables in the C++. So let us see the examples, all these examples running in the code blocks. So this is an example for ash, the first one, that is cout example. You can see here I have included ash include iostream. In code blocks iostream.h will not support, so that's why you have just written ash include iostream, and then I have written using namespace std and then int main. Within this I have declared the variable int x, then I have put the value x is equal to 10. Then I've just displayed cout is equal to cout and then the left shift operator. So cout together with the left shift operator and the x, then finally the end of main. So we'll just run this particular program, compile the current file, and then I'll run. So you can just see the output is value over here. You can see the value of x is nothing but the 10. So this is regarding the first example of the cout. Let us go to the second example. Again, this is an example for the cout itself. So I'll just compile the current file. Okay, so here same, I've declared two variables x and y. I've inserted two values, x is equal to 10 and y is equal to 20. Cout x, after that I wanted the value of y in the next line, so I've included this cout endl. Endl is nothing but, instead of what you've seen /n in the C programming, here we are going to use endl to insert the new line, inserting the new line by using the endl. And then finally what will be the output? We'll be displaying the value 10 and 20. So I'll just run this particular program. So you can see over here the two values 10 and 20 is been displayed. So this is regarding the example. Both examples are regarding the cout. Let us go to the program 3 where it includes cin as well as the cout. So here ash iostream.h using namespace std, two variables x and y. Cout I have taken enter two numbers /n. So you can see the double quotes over here if you want to print that particular statement, and then I've read cin, two variables I'm going to read from the keyboard, x and y. I mean x and y, I need to enter the two values. Cout again printf statement, you entered, and then again x, and within this double quote and y. So just let us run. So enter two numbers it will give. So let us enter 10 and 30. So you entered 10 and 30. So you can see whatever you have written. Here it came enter two numbers. Cin, write two numbers from the keyboard, 10 and 30. Cout, you have entered 10 and 30 is been getting displayed. So this is regarding the third program. The fourth program is regarding the variables, how we are going to declare the variables in the C++. So here I have declared int x, and then I put the x value is equal to 10. So value of x is equal to x. So what will be the output for this value of x is equal to, it will be nothing but the answer will be 10, and then I have declared int star pointer I have declared over there, and then within that pointer I have fetched the address. So iptr is nothing but address of x. Then I'm just displaying the address of x. Just now iptr, this will store the address of x, So whatever the address is there, that will be displayed in this particular thing. So address of x, and then again the new line. First it will print the value of x, then it will print the address of the x. So we'll just run this particular program. So you can see over here, first I declared int x is equal to 10, cout value of x is equal to 10 will be displaying, and then int star iptr. Over here iptr again I assigned a value and x, or else here itself I can put address of x and x, and then address of x iptr has been printed. So that is nothing but whatever this value is there, that is nothing but the address of the x. So this is regarding how we are going to declare the variables in C. Next concept is based on the function prototyping. Function prototyping is very necessary in C++. I'll let you know why it is very important. So let us basically understand what is a prototype. Function prototype is same as your function declaration. You have to just remember that function prototype is same as your function declaration, what you have learned in the C language. So a prototype here describes the function's interface to the compiler. What is the thing he is doing is he lets knows the compiler what is your function of what type, I mean what is the return type of your function, and what are the argument list is of what data type you have sent. So nothing but it tells the compiler the return type of the function, that is this, as well as the number, the type, and the sequence of its formal arguments. It tells what is your argument list, what is the type, or what is the number, or what is the return. The type is nothing but what is the return type, how many number of arguments are there, and the sequence of its formal arguments. So this is the major advantage of your function prototyping. It actually tells the compiler, while you actually write a code, it tells the compiler what is the return type of your function, so that he can expect the same return type, I mean value over there, and then as well as what are the number of arguments you are going to pass, and what is the return type of those formal arguments. So the data, I mean the syntax for the general syntax for the function prototyping is return type, your whatever the function name, and the argument list with the semicolon. So this is the syntax. Okay, so here for example, let us take an example of int add int comma int, int add int comma int. So this is an example. So this prototype indicates that add function returns a value of integer type. Okay, this prototype implements or indicates that add functions returns a value of integer type, and it takes two parameters where both the parameters are of integer type. Since a function prototype is also a statement, so this semicolon is mandatory. Since a function, whatever this prototype is a statement, so the semicolon must follow over there. And providing the names to the formal arguments, you can either pass like int a comma int b, or else you can just keep int itself. So that is optional. Even if such names are provided, they need not match the same names when you're going to define the function. For example, here you have written ab, then while calling the function, for example, while you're going to define the function, okay, int add, you can change it to like int b, int c and int d. This is also fine, and then you can go on defining. So this is regarding the function prototyping. Okay, function prototyping is similar to the functional declaration. The major advantage is that it tells the compiler what is the return type, as well as what are the number of arguments you are going to pass, and those arguments are of what data type. Okay, and this is the syntax over here. You can either pass the arguments, you can give the names and pass, but the semicolon is mandatory for this declaration. Since it is a normal statement, you should follow with the semicolon. So this is regarding the function prototyping definition and the syntax of the function prototyping. So let us see the example over here. #include iostream.h, which this is defined to read C in and C out with also the extraction and insertion operator, and using namespace std. Int add int comma int. So you can see same whatever I have defined over there, declared over there, same thing I have used over here. Then I have declared within int main. This is function prototyping or function declaration. Int xyz, these are the three variables I have defined. Enter two numbers. For example, let us take 10 and 30. I'll read 10 and 30. Z is equal to add 30, 10 and 30. X and y values will be passed. Z is equal to add function. So it will come to this particular function. Int add int a comma int b. So it will return a plus b. So what will be the output of this? It will return 10 plus 30, that is z will have the value of 40 and it will tell that sum is 40. So this is the example for the function prototyping where I have declared a function prototyping over here, function definition is over here, and that I've fetched and displayed over here. So this is an example. So let us see the output in the code blocks. So this is the program. So same program we have used over here. So just will run, build and run. So it's telling enter a number. So let me enter the same number 10. Enter the second number 30. So 40 is the output. So you can see XYZ I've defined. Enter a number, I've given X, enter a number, I've given X, then again enter the number Y, I've given Y over here, 30, and then Z is equal to add X comma Y. So when it is add, it will come to this particular function. Either you can, I've written directly over here, written A plus B, so it will return whatever the sum of those two values. X and Y had 10 and 30, the 10 and 30 will be passed over here, 10 plus 30 will give you the 40 and Z will have the value 40, and then finally I'm going to print, and then again in the end L is nothing but the new line you're going to insert. So this is regarding the example of function prototyping. Next we'll see the concept of function overloading. Next concept is based on the reference variables. Reference variables are nothing but they are the variables in their own right. That means in C++ we introduce a new kind of variable known as the reference variable, which provides an alternative name for the existing variables. For example, if we have an example like float, okay, float total is equal to 100 and then float and sum is equal to total. Okay, so here the existing name, so what is the reference variable? It is nothing but I am going to give a new name for the whatever the previously I have defined. Now for example here I have defined float total equal to 100. Okay, now what is the reference variable name? It is nothing but sum. It is nothing but the sum. For that the syntax is data type and then the new name is equal to existing variable name. So you can see here data type is nothing but float and whatever the reference variable name, that is a new name which you're going to give for the existing name, variable name. So this is the reference variable name and this is the existing variable name. Now what is the value of total now? The value of the total will be 100. Similarly, for example, if you just print the value of the total, it would be, if you just print, it would be 100. Similarly, if you just print the value of cout sum, if you just print the cout sum, even that value will be 100. So just remember that reference variable provides an alias or alternative name for previously defined variable name. For example, if you make the variable sum as a reference to the variable total, okay, variable total, then both can be used to represent that particular variable. A reference variable is created by using this particular syntax. That's what you have to remember. It is being how you're going to create data type and reference variable name is equal to or less than existing variable name. So this is the syntax. So as I told, I've given the example over here, float total is equal to 100. Again, if I want to give a reference variable name, then I just data type and sum. Now sum is nothing but the reference variable name for the existing variable name total. Here total is a float type variable that has already been declared. Okay, sum is the alternative name you're going to declare to represent the variable total. So both the variables refers to the same data object in the memory. If you just remember, both the variables will refer to the same data object in the memory. So when you print the statements, for example, if you want to print the values of both, it will be just 100. And in case if you do, like if you just change total is equal to total plus 10, for example, it will change the value of both total as well as sum. Both the values will be 110. Now for example, if I after these all statement, if I declare sum is equal to 0 now, it will change the sum value is equal to 0 as well as the total value also equal to 0. So a reference variable is a right, it can be initialized at the time of declaration. You can initialize at the time of declaration, and in C++ assigns additional meaning to this and. additional meaning to the symbol and. Here and is not an address operator. The notation, for example, the notation float and sum equal to total means whatever this notation float and sum, float and then sum means, what does it mean? It is nothing but this is reference to float. Okay, the notation float and means it is reference to float. Okay, so it's not only the address, in addition to that it tells that additional meaning to the symbol. Actually we think about this symbol is nothing but the address, in additional meaning to this and is nothing but the reference to the data type, whichever data type you're going to write, right? It may be int, it may be reference to integer type, it may be reference to float type, it may be reference to character type. So this is the concept of reference variables in C++. So reference variable is nothing but it is an alternative name for the existing variable name. And what does it do? Those are the variables in their own right. They are nothing but just a reference for the existing variable, and the values of both will be same. To define the reference variable, this is the syntax for declaring the reference variable: data type and reference variable is equal to existing. After that, whatever the value of this will be there, right, that value will be same for this reference variable name value also. So let us just see the example of this particular program. Reference variable. So ash include iostream.h using name, this already we had seen. Int x, then we are assigning x is equal to 10 value, and I'm just printing the x value. So now the x value will be nothing but output will be here x is equal to value of x is equal to 10. Now this statement is over here. I'll just repeat: int x, x is equal to 10. Now x stores the value 10, see out value of x, output would be value of x is equal to 10. Now I declared int and iref is equal to x. Int and iref is equal to x. Now what would be the value? Whatever x value is there, right, 10, same thing iref also will have the value. Iref also will have the value as 10 itself. If int, I just created an aliasing name for the existing variable. So this is nothing but another name for the x. Now what is this int and? This is of the type integer. This means that it is referencing to the integer type. It is referencing to the integer type. So iref also will have 10, x also will have 10. Now iref is equal to 20. Iref is equal to 20. When iref value is equal to 20, I printed x value. X value also will be 20. Now x got incremented, so it will be, when it comes out of the loop, it will be 21. So this value will be 21. X gets incremented means even iref value is also getting incremented. So this is what is regarding the reference variable. Okay, I hope it's clear with this particular example. One more example they have given is regarding the as passing as an argument. Okay, so you can see over here, this is an argument, passing reference variable as an argument. So here void increment, this is a function declaration, int and. So you can see here you pass the reference variable as an argument. Reference variable can be passed as a function argument. Over here void increment and int and, this is passed as an argument. Int main, int x is equal to 10, and then it will go to the increment x function. Increment x function means it will come over here. Okay, it will come over here. Now x is 10, so see out after incrementing what is the value. So increment x means it will come to this void increment. Here you can see it's passed as an argument. Reference variable is passed as an argument. Here I have declared, here I have defined the function. Within this you can see int and r, and then finally within this I am just incrementing the alias name what I have given, that is reference variable what I have given, r++. So it will come back over here. When I come to increment x, it will return the value of over here. Now r means what will be the value over here? 10 itself, because I have defined, right, int and r. So it takes the value as 10, so it will be 11. That value will be written and the value of x will be printed as 11. So you can also pass the reference variable as an functional argument. Okay, so just x is equal to 10, increment function. In that increment function, for instead of x, I pass the reference variable, and then I incremented that will return the value. You know, here x means 10, so here also and r will store the value 10, so it will be 11. That will return, and see out the value of x will be equal to nothing but 11. So this is regarding how you can pass the reference variable as a function argument. So these are the two examples for the reference variable. So reference variable, don't get confused, it is just an alternative name for the existing variable. And then what does it do? it is nothing but a reference for an existing variable. So whatever this you're going to write, right, this is the name, and this and is nothing but it means reference to that particular data type, instead of address. That is equal to existing variable name. Now this and this will occupy the same memory allocation, and both the values will be same. That's what you have to remember. Okay, so this is regarding the reference. Let us see the execution of these two examples in the code blocks. Okay, so this is program, one is this program and one is this program. So let me see, same program I've copied. Okay, same program I've copied over here. So you can see the first example what I had given, int x is equal to 10, cout x and l, int I created here, int and iref x. Okay, iref is equal to x. So here initially when I'll just run this particular program, compile current file, and then I'll run. Okay, 1 minute, just a minute, build and run. So check the output over here. I initially declare int x is equal to 10 initialize, cout x means the value will be 10 over here, the value will be 10, and then I have declared the reference variable, data type, and which is referring, that means what, it is referring whatever the reference variable created, that is referring to the integer type, that is equal to x, So int and iref is equal to x means, okay, here iref is a reference variable to the x. So this is how you, once you declare this particular, I have written, I have just commented, later I'll tell what is the what will be the value over here. Iref is equal to 20, again I declared. So what will be the x value now? X also will get the value 20. So cout x I have written. So once you created iref, x and iref are same itself, they are just aliasing. So x value also will be 20. So you can see here x value is equal to 20. Later I incremented the x value and I printed the iref value. X will be 11 now, 11. So x will be 20, iref was 20, right? So x will be 21, 1 incremented. So cout iref. So it is 21. So this is how we are going to execute the program. So I'll just, before that I'll just show you, I've put a comment line over here. I just added one more statement over here. Int and iref. Now you know that x value is 10, you printed. You created an iref for this, a reference variable for the x. So I just want to print what will be the value of the reference variable. So just compile again current file. Okay, or else build and run, you can give compile again. Build and run. See the value, I just, x was 10, I gave cout, I declared the reference variable, I gave cout iref, so again the value is 10. Then again I made iref equal to 20, I printed the value of x, so you know that x value is 20, I incremented x and then I printed the value of iref, so it will be 21. So this is how the execution of the reference variable takes place. Next is the same other example, that is passing the argument, formal argument. Okay, so I'll just again build and run. You can see the value over here. Okay, int x is equal to 10. Here it is passed as a formal argument, is a reference to the passed parameter. Here we have declared the increment function. Then int x increment x. Here I have given the normal variable name. Here I have given the reference variable name. So void increment r plus plus. That means what? It is same as x plus plus. So here the value x was 10, so it would be 11, and it will return over here, and it will print cout. So you can see the 11 over here. So this is regarding the concept of reference variables. Function overloading. In this process, it allows two or more functions to have the same name. Now what is the concept of function overloading is, for example, you have int add int a comma int b. Okay, one more example is int add int a comma int b comma int c. Okay, so here it allows these are the two functions, two or more functions to have the same function name but the signatures will be different. Same name but different signature. So function overloading is nothing but it allows two or more functions to have the same function name but the different signature in the sense number of arguments, whatever the data types, as well as the sequence of those formal arguments. Signature of a function means the number of arguments, whatever the data type, and the sequence of formal arguments of the functions, whatever the sequence is there, that to be different. Whereas function name can be same. Here you can see you have 2 arguments, here you have 3 arguments. Okay, signature is different. Said to be only if it has same name but different signature. Depending upon the type of the parameters that are passed to the function call, the compiler decides which of the values, which of the function should be invoked. Now, for example, in the program you will call a particular function, right? So, for example, I'll give an example like you are declared int add int a comma b. That means this and these 2 functions you have defined. Now, for example, in the main function I just printed cout. Okay, function calls. I have done function calls like add 6, 10. Okay, and then again in the main I have printed like add 5, 4, 3. Okay, so this is you have defined these 2 functions. Okay, int add int a comma b, int add int a comma b comma c. This is one prototype, that is this is one type of function declaration, prototype 1, and this is second prototype. So what is happening over here, function name is same but the arguments in this is 2, in this it is 3. So when I do cout, in the main program when I call the particular function, now whatever the function definition is somewhere else, I'll do the return this definition is somewhere else, like add. You have that particular function definition for both the functions. One more is for this. Okay, so I've called here. When I call this particular function, so which prototype will be invoked? So this will invoke this particular prototype. This will invoke this particular prototype based on what? Based on the signature. So depending upon the type of parameters that are passed to the function call here, the compiler decides which of the available definitions will be invoked. This is available, so this definition will be invoked for this, and this is available, this definition will be invoked for this. So this is the concept of function overloading. In function overloading, you can have the function name same, but the signatures will be different. And this is the syntax. This is a function prototyping syntax itself. If you remember the previous concepts, this is the concept of function prototyping itself. But only thing is, same name and different arguments. Based on the function prototype, function overloading is the beneficial. Okay, based on the function prototype, overloading is become easier, because that is where the function prototype actually comes in important role. Since function prototype is mandatory in C++, it is possible for the compiler to support the functional overloading properly. Other than that, function overloading is also known as function polymorphism. So just if you remember the polymorphism concept, what I've told in the features of object-oriented programming, it is nothing but which can exist in more than one form. That is the concept of function polymorphism. So function overloading is also called as function polymorphism. So let us see the example of function overloading. So over here I have declared 2 prototypes. Function prototyping I have done for the 2, int add with 2 parameters and 3 parameters. So here I have defined int x, y, z, and I have called x is equal to add, y is equal to add. So this when I go to this particular function, so it will invoke this function. When I go to this particular function call, it will invoke this. When x is equal to add 10, 20, it invokes this particular function, and that has been defined over here. So returns a plus b. What is that? Returns a plus b means x is equal to 30. When I call this particular y is equal to add, then function call, this function call, it will go to this particular function definition. So that is defined over here. Int add int a comma int b comma int c. So return a plus b plus c. So it will return the value, that is 50, 60. So 30 and 60 will be the output. So cout /n, next line, and then x value, whatever the x will display, and what is the x value? X is 30, and y will display, and whatever the y value, that is 60. So this is how it executes the function overloading. So let us see the execution in the code blocks. So same program I have run. Int xy, x is equal to add, matches first prototype, that is this prototype. This matches second prototype, and it goes to that particular function and executes. So cout x and y I have done. So just let me run. So you can see the value as 30 and 120. Maybe the values whatever I've told over there I've not given, that is 30, 40, I've given 30, 40, 50. So 50, 90 and 30, it would give me 120, and 10 and 20 it would give me 30. So this is regarding the function overloading concepts. Thank you.